N stands for number of trial undertaken, P stands for probability of success, and Q stands for probability of failure. Find the coefficient of first value of coefficient. The first value always in the coin 0, 1, 2, okay, like this. If expected frequency are required, multiply the probability by N. Okay, this is your very simple formula, expected probability. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 3, Session 8, third semester BCom, Probability Distribution, and today my agenda. So, in the last session I have explained which is related to the binomial distribution theory part. Okay, moving forward for the few problem, okay, with few examples problem. Under binomial distribution, binomial distribution is a probability distribution. Which distribution means which is a discrete random distribution. Okay, discrete probability distribution, which is expressed in the probability of one set of dectomass, which is their dectomass. Okay, two alternative, P stand for success and Q stand for failure. So the probability under binomial, okay, so X bar is always NP. Clear? So in this case, X is a discrete random variable with the probability mass function. When we are writing like this P of X, which is nothing but probability mass function under discrete method binomial. Okay. So here the formula NCX into P of X. N stand for number of outcomes. Okay. P stand for probability of success. Q stand for probability of failure. If you know the success value, easily you can find out Q value 1 minus success value. If you subtract, you will get the Q. N is a number of outcomes. X is a, okay, here where 0 is less than P, less than 1. Okay. So here the P of X, which is nothing but the probability of X event, what coin related or birth related. There are few examples for binomial examples in the last session. So here X is, if you are writing a capital letter, which is nothing but your random variable. If you are writing X small letter, so which is the experimental what and all, you are getting a result 0, 1, 2 till N numbers. Okay. So here N stand for number of trials undertaken. P stand for probability of success and Q stand for probability of failure. How we are getting failure? 1 minus P. Then X is a binomial variate because X, we are using a binomial distribution, okay, which is a James Bernoulli. Bernoulli distribution, which is a large samples we are taking, considering, and the distribution of X is called binomial distribution, which is already the theory part is covered. 1 second just for recalling here. Here there is one question for binomial distribution. In a binomial distribution, if N is equal to 5, okay, the small letter N is equal to 5 and P value, probability of success value is 1 by 4. Now find the mean and variance and standard deviation. So here the X bar, mean is nothing but X bar, N into P, okay, and variance formula, variance of X, which is nothing but NPQ. Okay. Now, if they are asking for to find out a standard deviation, if you are writing inside the square root NPQ. So, NPQ, NP, which is a parameters, which is in the binomial parameters. Okay. So, here whatever the given information I have written like this, N is stand for, N is given in the question 5. And probability of success 1 by 4. Easily you can find out failure 1 minus 1 by 4. If you subtract, you will get 1 minus 1 by 4. If you subtract, you are getting 3 by 4. So where you are finding a plus and minus sign, you have to find out the LCM. Okay, in case of if you try to go for LCM, here nothing is there, means denominator 1 you have to assume. Okay, and see which is your LCM 4. Okay, 1 into 1 4, directly 4. Okay, minus sign. So directly 4 cancel 1. If you subtract 3 by 4 we are getting. So now in the binomial distribution the mean is already written NP. Okay, now you know the value of N value and even the P value we got. So directly we can multiply 5 into 1 5 divided by 4. Here nothing is there, means you have to assume 1. 1 into 4 4. Now mean we got 5 by 5. 5 by 4 we got the mean. Now variance, because according to variance here NPQ is required. Q is also we calculated, we got 3 by 4. Now N is a 5, N plus we are writing 5, P plus we are writing 1 by 4, Q plus we are writing, just now we got the Q value 3 by 5. So direct multiplication, okay. 5 ones are 5, 5 3 is a 15. Okay, here nothing is there, 1. 1 you have to assume. 1 into 4, 4. 4 into 4, 16. So if you try to remove the square root, or if you try to convert into fractions value, we are getting 0.9375. Now, with the help of variance only, we are able to find out the standard deviation. See, the standard deviation inside the square root NPQ value we just now calculated. Otherwise, you can write like this. Okay, if you remove the square root, we are getting a standard deviation. Okay, that's it. Moving forward, next question. In a binomial distribution, if mean is 6, x bar is 6, and standard deviation is 4, and find the value of NPQ. Three value you want to find out using the mean value and standard deviation. The standard deviation you know, because the standard deviation, so if you try to convert square, which is nothing but 2 into 2, we are getting 4, which is nothing but variance. If you try to extend NPQ, variance is always NPQ. So here given information, mean is given and standard deviation is given. Now you need to find out NPQ value. So whatever I am doing here, in the binomial distribution, mean is a NP. So NP is equal to 6. Okay, here NP is 6. And the standard deviation, because we know the standard deviation value 2. Now if you taking for standard deviation 2 value, if you try to for expanding the variance NPQ 2 to the power of square, now we are getting 4. Now consider the ratio. What we are trying to do? First we are writing a variance divided by x bar value. Okay, variance we got here 4. Variance with the help of standard deviation we just converted for variance. So variance, mean is given in the question 6. Okay, so if you try to simplify, 2 2s are 2 3s are 2 by 3. Now easily we got the value. Now immediately Q you need to find out. So the same thing what we are try to do, extending here NP place, suppose if you are try to go for NPQ divided by NP value we know 6. Okay, 6 Q we don't know the value. Again here NP place 6 cancel, directly we can write Q. Okay, so which is extending one more time, that's what 4 by 3 and 2 by 3. Now we can simplify this value because we know the value for P value 1 minus Q. This is just finding the P value. Directly we are writing, yes, we have P 1 minus 2 by 3. If you subtract, you can get the value for 1 by 3. And mean value which is given in the question 6. Okay, so that n into p value, because just now we got the p value. Okay, so n into 1 by 6 is equal to 6. Or you can write like this, directly n into 3 into 6, 18 we are getting. So n plus we are getting 8 and p plus we are getting 1 by 3. How to find out Q? 1 minus p value 1 by 3. If you subtract 2 by 3 we are getting. So binomial distribution, here in the last section, in the last slide, which is related to the few problem binomial function. So now which is extending for the probability mass function. If x is a discrete random variable with the probability mass function, when symbolically we are writing p of x, which is nothing but probability of mass function. So the formula is very simple. NCX, n stand for number of outcome, C is a combination, x factorial, x value, and into p of x into q x n minus x. So where 0 less than p less than 1. So the p of x, which is nothing but the probability of x event. So where x series which is starting from the 0, 1, 2, 3 till the end result or end outcome. So n stand for number of trial undertaken, p stand for probability of success, and q stand for probability of failure. How we are getting? If you know the value of a probability of success, easily you can subtract from the total probability always 1. From the 1, if you subtract the probability of success, easily you can get for q value. So then the x is a binomial variant. Because we are doing a binomial distribution, we need to select the binomial variant. So then the distribution of x is called a binomial distribution, which is already I have explained the theory part in the even last section also. So now we are trying to do for probability mass function few examples. So there is one question. For example, if two coins are tossed one, okay, two coins are tossed one, okay, two coins if you toss tile, head, head. So what are the probability of getting 0 head? One question, 1 head, okay, and 2 head. Similarly, what are the frequency? 0, 1, 2 head. Okay, because 0 how many times is repeating? 1 head how many times you can expect? 2 head how many times you can expect? Which is nothing but your frequency. So using the information we try to convert in the tabular format. So the possible outcomes are, if you try to toss the coin, two coins, the same time you are getting tile. One time you are getting head, one more time is getting tile, or head or tile, or 2 times also you are getting head only. Because the question which is related to hex, you are expecting head means, so when the tile, 2 coins or appeared 2 tiles, then you are writing 0. Okay, 1 head, at least 1 head in this case, at least 1 head in this case, 2 head you are expecting last toss. So here immediately the success of getting head. P stands for success of getting head. Q stands for failure, not getting head. In this case only getting tile. So N stands for number of coin. Here the 2 coins we selected. 2 into 2, total result will be 4. Because 4 result we are getting. H stands for head, T stands for tail. So I think you got clear idea. So next, with the help of tabular format, if you make a frequency distribution, now what we need to do? Number of head, we need to consider x. So 0, 2 tile, 0, 2 tile, okay, at least 2 head, tile, head. So 1, okay, and the 2 head when it is getting 0, 1, 2. So 0 means no head, 1 time. There are 2 tiles only. So 2 times we are expecting head, tile, head. So 2 times we are writing. Okay, and 2 times you are getting head. So only 1 time you are expecting. So the total outcomes will be always 4. Now if you are trying to go for writing in the probability, the total outcomes in the previous slide, there are 4 possibility. Okay, that's what 4 possibility. The 4 possibility here, 1 by 4, 2 by 4. If you simplify 2 ones and 2 twos, that is also possible. In this case, here how many head? 2 head you are getting. 2 times you are getting head, 1 by 2. Okay, so the final, the probability total will be 1. In generally, in n toss of coin, n number of toss of coin, the probability of various possible event, okay, the various possible event. So that is obtaining 0 till number of coin. If you try to take for 3 coin means 8 result you are getting. So any event which is related to the binomial distribution event, experiment. So till n. 8 are given by the successive terms of binomial expansion, which is nothing but Q plus B. For example, if you are writing 0.5 failure and 0.5 success, the total n. So which, when you try to write in the probability mass function, P of x, because we need to select the x series value. So which is starting for the probability mass functions, just for your understanding, NCX, formula is NCX, x plus, suppose you are taking for P of x plus first experiment to 0. So 0, now n is a number of chances. Now you are writing x, n is equal to number of, okay, into c plus x plus we are writing 0 because we return probability based on the 0. Now the probability of success when we are writing, so the same thing, P of x plus 0 into Q of x plus n minus 0. So keep on, which is extending till the last value like 2. So in this case, till here 0 and till here 1 and till here 2, till the number of outcomes. Moving forward, these terms may be listed in the form of probability distribution. For example, n is equal to 2 because you know the clear value, the n value is a 2. Now you need to set for the probability distribution function. So here, which is nothing but number of head, which is nothing but your X series. Okay, 0, 1, 2. Okay, the number also you know, n is equal to 2. If you are writing in the probability, this format, P of X is equal to NCX, P of X, Q, n minus X format. So, you know the n value 2, which is given. So, first experiment which is starting for wherever you are finding X, you are just replacing 0. And P of X, X plus 0, Q, n plus 2, X plus 0. So, if you try to go, here you are getting Q to the power of n. So, something, even 1, X plus you are just writing for 1, 1, 1. Here 1 and P to the power of X means 1, Q to the power of n, n is a 2, 2 to the power of 2 minus X plus 1. So, like this, when your probability is extending till the last numbers, because in this year clearly specified n is 2. General form of binomial distribution which can be applied to each term, which is P of X, nothing but NCX, okay, which is n factorial format. Okay, so NCX place we are writing n factorial, numerator n factorial divided by x factorial into n minus x factorial. Okay, P to the power of x into q n minus x. This is your formula. Instead of writing NCX, if you try to go for combinations related formula, this is your combinations related formula. So P of X is a probability of getting exactly x success in the n trial. N success. Here x will be a 0, 1, 2 till n. Okay. From the n trials. Probability of success. That is getting desired event. You are expecting head means that is a desired head. You are expecting head means that is desired event. If you are expecting a tail means that is your desired event. So, Q is nothing but 1 minus P, probability of non-occurrence, or you can say probability of failure, because you are expected head. But if you are expecting a head, unfortunately you got tail means in that case. So, P of X is a capital letter X, which is nothing but random variable. So, from the experience event, so P of X, the first event will be starting from the 0, wherever your NCR format, NCX format, n plus 2, C, X plus 0. So, the probability of each coin, always you are getting 1 by 2 or 0.5. So, X plus we are writing 0 into Q plus 0.5, n plus n, n plus 2 minus 0. So, till the experiment will be extending till, okay. Find the coefficient of first value of coefficient. The first value always in the coin 0, 1, 2, okay, like this, based on the number of coins. So, here the experiment which is 0 and 1 and 2, that is nothing but your coefficients. So, they are based on the combinations principle you will need to follow. This is your combinations principle. So, P of X, NCX, if you try to extend the formula is n factorial. Suppose in this case n is assumed 2. So, if you try to convert in this format, n factorial, first one, n factorial means 2 into 1 divided by denominator x factorial, which is nothing but the first value if you take 0 factorial, okay, n factorial again 2 factorial means 2 factorial minus x factorial means 0 factorial, okay. So, in this format also you can try to solve. So, by definition 0 factor always you have to get to one value. P of X, NCX is equal to n factorial, same thing replacing the coefficient value. So, wherever which is starting from the experiment is 0, the x value start for 0. So, here 1 plus NCX, the first value 0 we consider, that's what we are getting 1. So, P plus the probability of success 0.5, the probability of failure we are getting 0.5. So, which is extending for the 1, 2, 3, okay, till the last number. So, if you simplify anything A and B, A plus B format which is equal, P and Q is equal. So, the common factors only we are considering. So, directly we can write like this, okay. So, moving forward. So, after writing the probability whatever you are getting, which is the X series 0, 1, 2 and the probability 0, 1, okay, one time only you are expecting, total outcome is the total probability 1 only. So, if you add together you are getting 1, okay. So, here the probability 1 by 4. instead of writing 1 by 4, I can write like this fractions value. So, one head, one tile, one head. 2 times you are getting the probability 1 by 2, or you can write directly 0.5. So, 2 head, only one time you are expecting, that's what you are writing 0.25. So, when you try to go for writing like this, this is also possible. The total probability value is 1. Okay. So, expected frequency how? With the help of probability mass function, we are trying to multiply with the respected numbers. Okay. Because in this 2 coins, we are expecting total outcome is 4. Okay. So, that is your nothing but n value, capital letter n value. So, n into p of x, if you multiply 1. 4 into 0.5, you are getting 2. 4 into 0.21, you are getting 2. The total outcomes is always is equal to 4 only. If expected frequency are required, multiply the probability by n. Okay, this is your very simple formula, expected formula. Number of outcome. So, now, binomial distribution, steps to be fit to binomial distribution. What are the different, what are the steps you will need to follow? So, calculate the mean. Okay, in the binomial distribution, x is equal to np. np is equal to sigma fx divided by capital letter. So, in this frequency, observation frequency, which is given in the question, with the help of observation frequency and x series, we are trying to find out the x bar value, which is very important for the fitting a binomial distribution, where x is the observed value, which is given in the question, and f is a observation frequency, which is given in the question. So, n is a total frequency, observation total frequency total. Now, second, once you calculate the first step, now you need to go for equate the observed mean value to theoretical mean of the binomial distribution, that is np is nothing but your parameters, or x bar you can say. Since n is given in the data, in the question they clearly specify, for example 0, 1, 2, 3, okay, till here in this case n is equal to 3 you can write directly. Suppose, which can be extending based on the question whatever it is given. So, p can be easily found out. Okay, so also Q also easily found out. So, when you know the value of n value, easily you can find out the n value or p value. N is given in the question. With the help of n, we are finding the value for p. Third step, find the theoretical probability x series. Small letter x is equal to 0. So, which is starting, the x value will start from 0. Using a binomial probability function, p of x is equal to x. Okay, now this formula is a probability mass function ncx, which is repeating again and again. So, p to the power of x, q to the power of n minus x. Here x is a number of the x value starting from 0, which is ending from the depend upon the experiment. For x, which is small x, which is 0, okay, or you can write 1, the small x can be a 2, so till the end result. So, p of x is equal to 0. When you try to go for selecting a first value 0, now x plus you need to go for 0, 0, okay. So, this is your probability mass function. Now, fourth step, find the theoretical frequency for x is equal to 0, E of x is equal to 0. So, now with the help of probability mass functions, we got the value of P of x is equal to 0. Now, you just multiply the observation frequency, total frequency, what we are getting. If you multiply directly, we can get expected frequency. Now, last fifth step is a round up the theoretical frequency whole number so that the total frequency of. Now, after getting a theoretical frequency or expected frequency, we need to go for round of next bigger value. Now, sixth one, write both the observed frequency which is given in the question and theoretical frequency we have calculated here. So, in the table, so that the comparisons can be easy. Suppose the observation frequency we are getting 100, even the theoretical frequency also we are getting 100, then the problem is tally. Moving forward, here the question 6 coin are tossed. Okay, now small letter n is equal to 6. 6 coin are tossed 64 times. So, which the capital letter 64 we are getting. After taking the frequency total, we are getting 64. So, here the question is very clear. 6 coin are tossed 64 times. Number of head observed at each thrown is recorded and the result are given below. Now whatever given number of head, you need to consider which is a x. Okay, and observation frequency we need to consider a f. Okay, so which is starting from 0 and with 6. Now the observation frequency which is given in the question, if you add together, you are getting 64. Now which is nothing but your observation frequency. Now what we need to do, so find the probability of 0, find the probability of 0, so 0 to 6 head, and also find the expected frequency as per binomial distribution. Okay, that means also find out the expected frequency, or you can fit the binomial distribution using this formula. Okay, so the probability mass function, whatever it is given in the question, I am writing like this. Small letter n is given 6 coin, and the probability, when the coin related, always the probability is 0.1, or you can write 1 by 2. Okay, the q easily you can find out. 1 minus 0.5, we are getting q value 0.5. So, or you can write 1 by 2. So, n, the total frequency, total capital letter frequency, 64. Now, x is a x variant, binomial variant, 0 to 6. Okay, when a coin is tossed, the probability of getting head, okay, the probability of getting head equal chances, no? So, that's what 0.5. Okay, and the probability of getting tail, that is a failure, which is related, the question which is related to always expecting for head. So, the failure is 0.5. How we are getting 1 minus 0.5? You subtract your q value. Okay, so using this information, we try to go for constructing the table. So, here the number of head and observation frequency, the experiment which is starting from 0, which is ending with the 6. Now, each and every stage we need to do for probability mass function. You know the formula NCx into P of x into Q to the power of n minus x. So, we have constructed table. So, now whatever given, which is nothing but x series, which is starting from 0. Now, observation frequency also given in the question. The first x series observation frequency is a 2. Okay. So, here the probability mass function which is starting from 0. So, the formula NCx into P of x into Q n minus x. So, wherever we are getting, so in this case small letter n is equal to 6, P value is equal to 0.5, or you can write 1 by 2, okay, and Q value 1 minus 0.5, if you subtract 0.5, or you can write 1 by 2, okay. So, here the x variance, you know whatever it's required for doing a probability mass function, the experimenter, the variant will start from 0. So, P of x, because x plus we are taken, we consider first value 0, okay, n plus we are writing 6, c as it is, and x plus 0, because we are doing experiment which is related to 0, okay, and the probability P of x is nothing but 1 by 2 to the power of 0 into q, you know the value of q 0.5, you can write 1 by 2. So, here if you try to go for 6 factorial, always giving one value, and see when which is a common, P and Q is a common, the common factors will be always to the power only 1, okay. So, when common factors, when we are writing, so you can extend like this 1 by 2 to the power of, so here 1 by 2 to the power of 6. Again 1 is multiplied 6 times, 2 is also multiplied 6 times, okay. If you simplify, finally we are getting 1 by 64. Now we need to multiply, we need to get a expected frequency. Why we are doing for expected frequency? Just to fit a binomial distribution. So the formula is very simple. Just now we got the value of P of x. Now you have to multiply the frequency total. In the last, in the problem, the frequency total we are getting 64. We are multiplying. So whatever which is given, so if you are directly 64 cancel directly 1, okay. Moving for next binomial variate 1 value. Here just now we did for the x series binomial variate which is 0. Now moving for the 1, okay, the P of x is equal to x plus we are writing just for 1. Okay, n place we know the total 3 coins, 6 coin. 6nc, x plus we are writing 1. So the probability 1 by 2, x plus we are writing 1. Okay, and q plus failure we are writing 1 by 2, n plus 6 coin, okay, minus x plus 1. So if you try to go for combination, okay, so the 6 is one time only, 6 into 1 and 1. So directly the 6 value will be direct, we are writing 6 into 1, 6. Okay, the which is a common, p and q is a common. So we are writing 1 by 2 to the power of 6, plus minus cancel directly. So we are writing. So as it is, the 6 will carry, and the 1 is 6 times you have to multiply, the 2 is 6 times multiplied, and the 1 as it is you are writing, and the 1 into 6 time you are getting 1. 2 into 6 times 64. So the final 6 by 64. Now you need to multiply with the n. Okay, the total frequency, observation frequency. 64 cancel. 6 as it is we are writing. Okay, now moving for the next variant 2. So p of x plus we are writing 2. N plus we are writing 6 is 2. Okay, the probability 1 by 2, x plus we are writing 2, and q value 1 by 2, n plus 6 minus 2. Okay, now 6c2, how we are extending here, 6 into 2 times means reverse you are going, 6 into 5, 2 times, divided by 2 into 1 time you are going, because 2 is there means 2 times. Okay, both the numerator and denominator. 6 5s are 30, 2 ones are 2. So 2 ones are 2 15s are we are getting. So here now n 6c2 value 15. So here same p and q is same, plus minus cancel, plus 2 minus 2 cancel, the remaining because which is a common, both p and q value is same. So that's what we are writing 1 by 2 to the power. Now you need to extend the 15 as it is I am carrying. Okay, so 1 is 6 times and 2 is 6 times multiply. So here finally we got 15 into 1, 15 divided by 64. Now you need to multiply with the 64. The 64 is common, so we can directly cancel, the 15 will carry. Next one, the next variant is 3. Now the x plus we are writing 3. X, wherever you are getting x, we are writing 3. Now plus 3 minus 3 cancel, the same procedure. Now 6 is 3 times you have to go for reverse multiplication. 6 into 5 into 4. 6 into 5 into 4 divided by 3 into 2 into 1. Okay, now if you multiply 360 we are getting, divided by now 6. If you try to multiply the simplified, you are getting the total 20 you are getting, 6c3 is a 20. So here the same thing, that 20 will carry, 1 is the 6 time multiply and 2 also 6 time multiply. So the 20 as it is I am writing. So if you multiply numerator we are getting 1, denominator we are getting 64. Okay, now the answer will be 20 by 64. Now you have to multiply with the n, 64 common, so which is cancelled. Now 20 as it is. Moving for next variant, fourth variant. Now x plus we are writing 4. Okay, wherever you are finding x we are writing 4. Okay, now n plus 6. 4 times you have to go for reverse. 6 into 5 into 4 into 3, because 4 is given, divided by 4 into 3 into 2 into 1. Okay, if you simplify directly we can get 15. Okay, so now the which is a common value 1 by 2. So that the as it is the 15 will carry, 1 is 6 times and divided by 2 is 6 times. So 15 as it is we are writing, 16 into 15 into 1 we are getting 15. 15 by 64, 16 for 64, and you have to multiply with the frequency. Now 64 directly cancel, 15 as it is. Next variant is x 5. Now 5 plus x plus we are writing 5. Wherever you are finding x we are writing 5. Okay, now n plus we are writing 6. If you simplify, say 5 times 6 into 5 into 4 into 3 into 2 into 1. Okay, divided by now 5 times, no, 5 into 4 into 3 into 2 into 1. If you simplify, now directly we are getting 6. Okay, now which is a common value, p and q value common, only one time you are writing, the 6 as it is I am writing. So 1 into 6 time, okay, 2 into 6 time, if you multiply the 6 into 1, 6 divided by 64. Now you have to multiply with the n value. Okay, n value are multiplying, 64 cancel, 6 is the remaining. Now last variant is a 6. Okay, so x plus we are writing 6. Wherever you are getting x, we are writing 6. 6, 6, 6. Directly 6. Oh, now if you try to solve 6 into the 6 factorial, numerator also 6 time and denominator also 6 time, directly cancel, we are getting 1. Okay, so which is a common value, directly we are writing. So 1 is a which will carry, and 1 is 6 time and 2 is 6 time. So directly 1 into 1. So 61 divided by 64, 64 cancel and 1 is remaining. Now observe, if you take the observation frequency whichever is given in the question, you are getting 64, and if you take the total of an expected frequency also getting 64. Okay, keep on watch for next section. Thank you.